In this video, we are going to explore the next topic in the fourth unit, which is backpropagation through random operations. As you all know, what is backpropagation and how this backpropagation works in the neural network. Now, what is this backpropagation through random operations? So here, the backpropagation through random operations uses the fixed random matrix to update the weights. So backpropagation is an algorithm which is used in the neural network to train the model by updating the weights to minimize the error between the original value and the predicted value. Backpropagation algorithm works in four steps. Okay, the first one is the forward pass and then calculating the loss, then backward pass, then update the weight. In forward pass, inputs are passed through the neural network and give the output. And then this will compute the loss. Okay, that is the output is compared to the actual target by using a loss function. Okay, normally the backpropagation algorithm uses the mean squared error, which is the squared difference between the predicted value and the original value. Then once mean squared error is computed, that is a loss is computed, then this will perform the backward pass by propagating the error backward through the network. So here the gradients of the error with respect to each weights are computed. Then this will update the weights and these new weights are backpropagated to the input layer, to all the layers in the neural network to perform the operation. This figure shows the working of backpropagation. So here in the forward pass, okay, the input, there are four neurons in the input. One is X1, X2, X3 and X4. These input neurons are connected with the neurons in the hidden layer. So here there is a connectivity between input to the hidden layer by using the weight matrix. Then Okay, this will apply the function, then compute the output. So here this is the predicted output. So in the forward pass, the input is passed to the hidden layer and which is applied to the function to predict the output. Then this will compute the error between the predicted value and the actual output. Once the error is computed in the backward pass, this error is sent back to each neuron in the backward pass. Okay, the output error is sent to the hidden layer and the hidden layer, the error is sent to the input layer. So here the gradient of the error is calculated with respect to each weight. Okay, this is how the backpropagation algorithm works. Okay, next we see how the backpropagation algorithm works by using a numerical example. So here we are going to use two neurons in the input layer and one hidden layer with the two neurons. Then one output neuron, and this will uses the activation function as the sigmoid. Then the loss is computed by using the mean squared error. So here these are the initial values assigned to the neurons in the input layer and the hidden layer. Then the weight and the biases assigned to the network. So first the input layer consists of two neurons. One is X1 which is assigned with the initial value 0.05. Then X2 which is assigned with the value 0.10. Then the actual target value, that is only one neuron in the output layer, which consists of the target value as 0.01. And the weights in the hidden layer, there is a connectivity between the input node to the hidden nodes. So here W1 is the X1 to first node in the hidden layer and W2 is the weight between X2 to the first node in the hidden layer. Then the weights are W3 and W4. Then there are weights in the hidden layer to output layer, which is W5 and W6, and there is a bias. The bias for the hidden layer is 0.35 and the bias to the output layer is 0.60. Then this will uses the sigmoid activation function as 1 by 1 plus e power minus x. So here there are two neurons in the input layer, okay, which is x1 and x2. Then there are two neurons in the hidden layer, then only one neuron in the output layer. So here the input x1 to this is w1 and x1 to this node is w2 and x2 to this node is w3, and x2 to this node is w4, and this is the hidden layer. From the hidden layer, the weight to the output layer is w5, and this node to the output layer, the weight is w6, and this is the predicted output y, and the actual value for this y is 0.01, and there is a bias which is assigned to nodes in the hidden layer, and there is a bias which is assigned to nodes in the output layer. Okay, these values are represented in the network like this. Okay, then there is a forward pass in the neural network. So in the forward pass, first this will compute the value for H1, that is the first node in the hidden layer. So here it uses the formula sigmoid of there are two input neurons. So X1 which is multiplied with W1 and which is added with the second input neuron X2 which is multiplied with W2 and the bias. Okay, these are the values we have seen in the previous slide. Okay, now these values are, this weight is multiplied with the value of neurons and it is added with the bias to the hidden layer, and the sigmoid activation function is applied, and we get the output for H1 as this value. Then the same procedure is applied for H2, and for H2 this will multiply X1 with W3, X2 with W4 and add with the bias to get this output. Okay, now the value for H1 and H2, that is two neurons in the hidden layer, are computed. In the same procedure, this will compute the value for output layer y cap. So here sigma of this will multiply H1 with the weight W5, then H2 with weight W6 and add with bias to the output layer B2 and apply the sigmoid activation function. So here we are getting the output as 0.75136 from the input layer to the hidden layer, from the hidden layer to the output layer. Okay, the next step is to calculate the loss. Okay, for computing the loss, this uses the mean square error, which is the square difference between the actual value and the predicted value. So here the actual value given in the problem is 0.01, and which is subtracted by the predicted value from the network, which is 0.75136 the whole square. Now we are getting the output as 0.2748. So in the previous slide, we have seen about the forward pass and the computation of loss. The next one is the backward pass. So in backward pass, error is computed and it is back propagated to the previous layers. So here the error is computed at the output by using the formula y cap minus y, which we are getting the value as 0.74136, and then dou y cap by dou net 0, which we are getting the value as 0.1868. These two values are multiplied to find the error. Okay, now it is 0.1385. So to this back propagation algorithm uses the gradient. So gradient for the weight W5 is computed by multiplying the output produced in the previous step with the first node in the hidden layer. Okay, now eta output into H1. Okay, now it is 0.1385, and the H1 value we computed in the previous step as 0.59327. Now we are getting the value as 0.0822. Okay, the next step is to update the weight. So for updating the weight, we need a learning rate. Now the learning rate eta is considered 0.5. We are updating the weight for W5. Now this weight is updated by using the formula W5 minus eta into dou loss by dou W5. Now this 0.40 is the original weight value for W5 minus, which is multiplied with the learning rate 0.5, and this 0.0822 is the value which we have seen in the previous slide. Now we are getting the new weight for W5 as 0.3589. Now this new weight value is back propagated to the H1 layer. In the same way, all the other weights are computed, that is W6. Then the error in the hidden layer are back propagated to the input layer. Okay, this is how the backpropagation algorithm works to update the weights and train the neural network. Okay, the next one which we are going to see is the back propagation through random operation. So here this random back propagation is a variation of the back propagation algorithm which is used in the neural network. So here the random back propagation algorithm uses the fixed random matrix to update the weights. So instead of using the transpose of the forward matrix. So here this means that in a backward pass where the errors are propagated to adjust the network weight, it uses the random connection instead of the standard symmetric connection. Okay, let's see how the random backpropagation algorithm works with the numerical example. So here there are two neurons in the input layer, then one hidden layer with the two neurons, and then only one neuron in the output layer. Then it uses the sigmoid activation. Then last is the mean square error. Then it uses the fixed random weight matrix instead of the transpose of the weight. These are the initial values assigned to the parameters in the neural network. There are two neurons in the input layer which are assigned with the values zero point 0.1 and zero point 0.2, and then there is a weight between input to hidden. So the input to hidden is given by the weight matrix zero point 0.5 minus 0.04, then 0.3, 0.2, and there is a connectivity between the hidden node to the output node which are given by the weight matrix WHO, that is hidden to output layer, which is zero point 0.2 and minus zero point 0.1, and there are biases. The hidden layer, the bias is zero point 0.1 and zero point 0.1, and for the output layer the bias value is zero point 0.1, and the actual target value is y is equal to zero point 0.5. Then it uses the random feedback matrix BHO, that is hidden to output, which is given by 0.7 minus 0.3. The first step is the forward pass. In the forward pass, this will compute the value for the nodes in the hidden layer and nodes in the output layer. So here it uses the formula WIH, that is the weight from input to hidden node, which is multiplied with input neurons and added with biases of the hidden units. Okay, now by applying all the given values, now we are getting the two values. One is 0.03 for H1 and 0.17 for H2. Then it apply the sigmoid activation function for these two values, and it will produce the output as 0.5075 for H1 and 0.525424 for H2. Then after the hidden units are computed, then this will compute the output by taking weight from hidden layer to the output layer, and which is multiplied with the value computed in the previous step, which is added with the bias to the output layer, and apply the activation function, and this will produce the output as 0.5377. Okay, the next one is the compute output error. So here this will compute the error by taking the actual value and the predicted value. So here A, O is the output given by the model, and Y is the actual value for the output. Now the model predicted the value as 0.5377 and the actual target value is zero point 0.5. Now these two are subtracted to compute the error. Okay, then the error is computed by multiplying error with sigmoid of z output. So here it is 0.0377, and which is applied to the sigmoid of output to produce the error. Okay, the next step is backpropagation error through the random weights. So here it will use the random fixed weight matrix. Instead of using the WHO transpose, it uses the random weight matrix. So here it uses the formula delta H is equal to BHO, which is the BHO is nothing but the random weight matrix, which is multiplied with the delta output, which we have seen in the previous step, and then dot product of a sigmoid of ZH. Okay, first this will compute BHO into delta O. This is the random weight matrix which is multiplied by the value which we have seen in the previous step 0.00938, and we are getting these values. Okay, now this will apply the derivative of sigmoid for each ZH, and we are getting the value as 0.24994 and 0.2482. Okay, now this delta H is equal to this value 0.00657 and minus 0.00281, which is multiplied with the dot product of this, and finally we are getting the value as 0.00164 and minus 0.00070. Next one is to update the weights by using the gradient algorithm. So here the gradient algorithm needs the learning rate. eta, which is assigned the value 0.1. Then this will update the weight between the hidden layer to the output layer by applying this formula, and then update the weight from the input layer to the hidden layer by using this formula. Then we are getting the new weights like this, which are assigned to the input layer. Okay, this is how the backpropagation algorithm works by using the random operation. Okay, the normal backpropagation algorithm uses the transpose of a matrix, but the random backpropagation algorithm uses the fixed random matrix to update the weights. Okay, the overall summary of the random backpropagation is it is the training method for neural networks where the error signal is propagated backward by using the fixed random matrix which is used to update the weights. Then this will perform the operation by using a forward pass, backward pass. In the backward pass, then this will use the fixed random matrix to propagate error backward in the network. Then the weights are updated using the random gradients.